Um, so, friends, the answer, while seems a little, straightforward and simple, uh, it is about, learning to, what shall I say? It is something that you will always learn it afresh. The problems that are going to be there with reference to monitoring and maintenance, whatever tools, whatever armory, whatever shielding that you are ready with, whatever things you're ready with, you never know how things are going to, come up in the other way. So every time you'll have to probably relearn the wheel and have a strategy come out. But the general framework of things, like Sharath has mentioned, is pretty much the same. So I'd like to ask Bharani, with reference to his experience of having executed so many projects and many of them running successfully. So, in your opinion, what do you feel is the cycle for update? All right, is there a thumb rule, or how do you judge or decide before you give it for production level or the client side?
Okay. Thank you so much for that question, Nitin. Usually people assume that building a machine learning algorithm is one-time task. I build the model, deploy the model, job done. That's not the case. Usually your senior data scientists spend a lot of time understanding the business problem, building the model, evaluating that, and deploying. Post deployment, the junior data scientists take up the task of monitoring the model on an ongoing basis. And Sharad has already spoken about data drift, about model drift, right? And we also have something called as concept drift, and we have a lot of other things. Data drift means the underlying data on which you have trained your model changes significantly. Maybe age as a column in my project was in between 22 to 68 years. That was a range. Eventually, this particular bank ventured into education loan. So the underlying data started having data of 12 years, 13 years, 14 years lapse. So the underlying data changed. Hence, we had to retrain the model. Okay, and if the model accuracy when you have given the model to the customer was say 92%, and over a period of time, because of whatever reasons, maybe the accuracy kept on decreasing. So usually the industry norm is 5%. If you see 5% change in the accuracy of the model, either ways, good or bad, you'll have to analyze why it is good, what changed because of which you are having better accuracy now, or what changed because of which your accuracy has reduced. You'll have to relook at it. Third aspect is you need to look at something called as PESTEL, PESTEL, political. If there is any political change, for instance, when Donald Trump was US president, he has laid certain, his team actually has put down certain rules saying that people who travel from certain Middle East countries or Islamic countries into US, they were not supposed to carry laptops along with them. Even in business class, it wasn't allowed. So the prediction models which were built to predict the load factor, occupancy percentage of different flights has gone haywire. The prediction models have gone haywire. They were acting weird. Why? Because that's a sudden political change and people stop traveling because they know that, we cannot carry laptops. So a lot of business users stop traveling. And the model prediction versus the reality, it wasn't matching. So whenever you have such political change, you will have to relook at your underlying data. When I say political, what bill is being passed in the parliament is also something which people have to look at. Of course, the junior data scientist or data scientist might not have a keen eye on that, but your chief data officer or chief data scientist has to keep a tab of all such things. What if there is a law introduced which says that only electric vehicles should be there, electric vehicles of so many watts should be used, so on and so forth, right? So all those things have to be incorporated into the models that we build. Economic change. There is a recession going on, across the globe to a great extent. So it's an economic change. So the buying patterns of the people will change. People who are investing money in purchasing properties might change, right? Their behaviors change. Social change. We had COVID. And because of COVID, the way we deal, the way we interact with the people, everything has changed, social distancing, so on and so forth. So there has been a change. Because of that, the kind of data which gets generated also changes. A lot of people sitting at home started ordering food, right? So a lot of people, stopped going on international vacations. So aviation industry data got changed. And whenever you have technological changes, maybe you were manually recording the data in the past. People were manually resorting to record the data. And maybe they upgraded their systems now. They have automated certain aspects and now it's digitally getting recorded. So whenever we have such technological change also, we need to take an action in terms of upgrading the model. Any environmental changes, any legal changes, right? If you have a reorg, a new person has come in, for example, as a CEO, the first thing they might want to do is relook at the processes, change processes, etc. That would change the underlying data also. So you always have to keep a tab on these aspects and figure out on when to actually upgrade the model. So if you ask me, is there a generic thumb rule as such for these kind of things? We do not. But usually with respect to the amount of data, if you have more than 20% of data, you trained on some amount of data. If you have 20% of this trained data, which is coming as a new data, then you retrain your model. Or if your accuracy is dropping by or changing by 5%, that is when you might want to intervene and take necessary action. So these are a few aspects which people have to focus upon when it comes to model upgradation, monitoring and maintenance. Yeah. Thank you.
Thank you, Bharani, for that elaborate and detailed answer, especially the insights with reference to the external factors that. Yeah, Bharani. Yeah.
One more thing I forgot to inform is that we actually are doing a lot of manufacturing analytics, wherein we use a lot of IoT sensors. When you use IoT sensors, there'll be a lot of wear and tear, right? Devices get damaged. There'll be a lot of fluctuation. So, and there'll be a life for each and every sensor. You install a sensor, it will work for the rest of the life, but it doesn't work that way, right? So they might get damaged, or over a period of time, they might get degraded because of excess heat or whatever. And they might start, sending wrong data to you. So you can also define a rule which says that once in every 6 months, we will, recalibrate or we will replace the sensors. And because of that, we might get new data and we'll have to retrain. Okay, so that's another thing that I wanted to add. Yeah, over to you.
Yeah, right. That was I myself coming from the manufacturing line. Yeah, we have policies in place where calibration data, it's generally within a year, and certain very big instruments, it is 3 years, up to even 3 years. So any recording devices in a reasonably good size company, which is going to invest in IoT sensors for process improvement, will have calibration strategies in place, and because of which certain changes data may come. And yeah, so the thing that I wanted to, while Bharani was giving the detailed explanation, I was reminded of another YouTube video that I saw about some absurd studies. While it is not directly related to the monitoring and maintenance, but again, it is something interesting. I thought I'll just share. So somebody had made a study that people who in the US specifically, people who study, who go to college, who graduate, the probability of them being poor is very less. So college education versus economic prosperity is having a very high correlation is something that guy was trying to tell about it, which seems pretty obvious. All right. College education and the prosperity, or seems to be pretty obvious. Somebody had debunked that particular, which nobody would argue on this. But there was another person who was arguing that we go one step back. College education versus existing economic index has a much higher correlation. Most of the people in the US have college education, graduate level college education, because they are already financially affluent. The poor people, it is very difficult. They have only less than 1% scholarship for poor students, and everything else is pretty expensive. So the fact that having a college education and not being poor is an absurd relationship altogether. All right. So I thought I'll just again, very, very commonly and well understood and well agreed upon statistic, college education versus economic index, has been totally debunked. All right. So that is why we need to probably, sometimes even reinvent the wheel and try to question everything before we can actually come to the conclusion. Thank you so much there. And also, sorry for the slight detour that I've taken. So yeah, Sharath, back to you. We were discussing about, hardware, server capacities, etc. You had mentioned. So my question to you is there some kind of a requirement that you are going to demand of your customers with reference to the hardware, or do you work with their existing setup and try to fit in? How does it really work? How do you choose the hardware requirements?
Well, Nitin, yeah, this is another very important aspect which the data science community probably does not get directly involved. But if you are dealing with data science projects or data related projects, as a project manager or as a manager who's trying to take care of these projects, you would probably look into these requirements very carefully. And you are going to draft, it is always very straightforward. Correlation is there, which basically talks about what is the volume of the data that you are going to process and what is the hardware standards that you are maintaining. And it also adds, if your data is too complex and if you have to rerun the algorithm multiple times, multiple iterations. So all these things are ultimately depending on the hardware, the computers, the server's capacity. So you should not undermine this particular important aspect. Now, you're not an expert. As a data scientist, you should probably be focusing more on the business aspects of the things, machine learning aspects, trying to solve the business problems and all that. But as a manager, especially if you are in that role, you would definitely try to consult your operations team, your hardware servers team and all that, and then try to do a benchmark. So before we actually jump into doing the requirements gathering and say, hey, these are the requirements that we need, we do benchmarking. So we take small data set, sample data set from the client or whatever the data that we have received, right? So we quickly check. And it's again an ongoing process. And one of the important aspects is that scalability is also to be considered. Because as I said, today's requirement might be for 1 GB data processing. Tomorrow, if the business grows, you will have to probably deal with 1 TB of data. Is your hardware capable to support that? This is one of the important question which is being addressed by cloud services. And this is also one of the reasons why the world is inclined towards the cloud platforms. And again, as I said, there are no standards as such that we'll have to use for hardware selection, but it is always an ongoing process, and we keep ensuring that the services don't go below the performance thresholds. And you may not always get the required hardware because there will be obligations with respect to the budgetary constraints could be there, the legal constraints could be there, data security constraints could be there. For example, when we were working on one of the projects with respect to Malaysia client, We did try to have the cloud, right, as one of the cloud platform, but we couldn't because of the data clauses, data security clauses. We couldn't use the cloud platform. We couldn't upload the data. The client was very right adamant on not using a specific cloud that we suggested because of these rules, right? And so, as I said, hardware is something that you'll have to always negotiate and try to get good hardware resources so that your training also is smooth, and after training your deployment also, and your client also is not, right, looking at the performance of the model, and they don't get that, right, slow, right. I mean, I should say that the performance of the model should be in such a way that the negative impact should not be created there, right? So it's ultimately a service that we are giving.
Yeah, thank you. On that note, just to add what Sharath had spoken, the GDPR requirements, especially in Europe, suddenly they had started this requirement that their data cannot reside anywhere apart from their own countries or inside the European Union. And many people, in fact, big companies, I don't want to name now, very big companies that we had discussed, whom we know as our top companies, were suddenly at a loss. How do they work? They said, you send your team here to work on us. We will not let you access our data from our servers all the way to India, to Bangalore, to Cochin, etc. So it can happen. These kind of surprises also can happen, and you should be ready for those things as well. So monitoring and maintenance, like I said, is another big air pocket in the journey, the flight journey of the data science. We have to be, if you clear that, okay, you can never say that if it is over, because you never know, it is going to be needs to keep moving on. It's not a journey that stops and you reach your destination. It's an ongoing journey. So on that note, we need to stop here for the monitoring and maintenance, and we will discuss a lot more on these things. And like we discussed, like we informed you, starting next week, we'll be going deep dive into various ML topics, into the depths of it. We will try to dissect it, maybe not just at the organ level, but even to the cell level. We try to dissect it, keep dissecting it, so that everybody gets a clear picture on that. Thank you so much.